Okay, so solve by factoring. Which method is this? Complex, right? So the thing about complex, I mean, just the word itself, complex sounds fancy. So this one right here, it's quite a bit of work, but it's still doable. When we start off a complex, we multiply the first with the last, so we get 6. We make the list, 1 and 6, 2 and 3. We're trying to make 7, so the only one that can make 7 is this one. And then everything's positive there, so this has to all be positive also. So the thing about complex is we're actually going to rewrite the problem into a grouping question. Grouping is the only one that uses 4 terms. So the 2 numbers that we found here, we actually swap them out with that 7. So this becomes plus 1x and then plus 6x. We'll bring the first one and the last one down. And now we can do the grouping stuff. So we take out the GCF of each one. So for the first one, it's x, and then you're left with 2x plus 1. The second one would be a 3. So then that's 2x plus 1. So then the GCF overall is 2x plus 1. So we pull that out and put it in front. And then those original GCFs, they become, I don't know, I put plus there, that's not supposed to be there. They become the second set of parentheses. So it's x plus 3. Now, again, you guys have to know the difference between factor and then actually solving. Right there, what I have on the board, that's factor. Now we have to take it that extra step and we actually have to solve it. So to solve it, we just take each problem and set it equal to 0. 2x plus 1 equals 0, and then x plus 3 equals 0. So I'm going to subtract 1 from both sides. So that's 2x equals -1, and just divide 2 to both sides. So that means -1/2 is a solution. And then we subtract 3 from both sides. So that means x equals -3 is the solution. And by the way, all of these, they're parabolas. And these answers we keep finding, it's where they cross the x-axis. That's what zeros are, or the solutions. Okay, today's notes, they're going to be pretty short. So hopefully you guys can pay attention for that short amount of time because it's going to use a skill that a lot of people forget how to do. The skill is division. A lot of us get comfortable with just typing stuff in the calculator, and we forget how to do long division. So I want to go off to the side here. I just want to review like how to do a long division question. So if I was to do long division, I'm just going to pick a bunch of numbers. 257 divided by 3. So what I want you to think about is the steps, because what I'm going to claim to you today is that the steps are exactly the same. So when we do long division, we try to see how many times the 3 goes into 2. And it can't because 2 is lower, so it can't go into it. So then we consider the 2 numbers. So how many times could 3 go into 25? Yeah, so basically we're doing like 25 divided by 3. And if you did that in a decimal, it'd be 8 point something. So that means it goes in 8 times. Now once you figure out what you put on top, you always multiply it to this one that's in the front, and that gives you 24. So you put it under here, and then after you put it under there, then you're supposed to subtract them. So then we end up with a new problem. So we subtract, and this is 1, and then we bring down the 7. So that's the new problem we do. Now we try to see how many times 3 goes into 17. So if you're not sure, you can type it in the calculator and actually divide it. 17 divided by 3, what is that, like 5? Without going over, it would go in 5 times. So once we figure out what to put in there, we put the 5 up here, and every time you put something up here, you multiply it with the number that's in the front, and then that's 15. And then we subtract again, so we change the sign, and that gives us a 2. Now at the end, we call that the remainder. So the remainder would just be 2. That same concept and those same steps are used with polynomials. It's 3 basic steps. You're going to first divide. I usually refer to this as stacking. And you'll see what I mean in a second. So what you're going to do is you're going to take the first term from inside the division house and stack it on top of the first term that's on the outside. So that's going to tell us like how many times it goes into it. After that, that tells you what to put on top, and then you're going to multiply. And then after you multiply, then you just subtract. So the first thing is These are not written as long division problems. They're written as fractions, but fractions mean divide. So to transfer this into a long division problem, the top goes on the inside. So we have x squared minus 3x minus 10. And then the bottom goes on the outside. So we'll have x plus 2 out here in front. Now I'm telling you, the steps, they're all the same. It's the same 3 steps that we did up in the problem above that only had numbers in it. So the only thing that is a little bit different is I usually do some work off to the side, because when I tell people how many times does x go into x squared, they get confused. So if you really want to see like what's supposed to go up here, this is what I say. Take the first one from the inside and stack it on top of the first one from the outside and simplify. So we do x squared divided by x. What does that simplify to? Just regular x, right? So that tells us that's what needs to go on top. Now, as you guys are putting it on top, put it above its like term. So the x would go right here. Now, anytime we put something on the top line, then we have to multiply it to this stuff. But the thing is, there's 2 of them. So we're actually going to have to distribute. So we do x times x, that's x squared. And then x times positive 2, that's positive 2x. Now in long division, after you figure out what goes underneath here, then you have to subtract. But the thing is, we have to subtract an entire quantity. So before you write this, just kind of pay attention to this part right here. We have to subtract all of this. So it's like putting a minus here. Yesterday when we did subtraction, we learned that when there's a minus, all it does is change all the signs. So instead of doing that, instead of putting in parentheses and subtracting the whole thing, I'm going to subtract it by changing every sign. And then this is going to create my new problem. So my new problem, just cross this out. Negative 3 minus 2x is negative 5x. And then we bring down to negative 10, just like we did in the other long division. So now that's the new problem. Just like up above, you guys, all these steps are exactly the same. Right now we're at this step. That's the new problem. So then we start the process all over again. So it's like an algorithm. An algorithm means you just keep doing it over and over and over until you run out. So now we stack it again. So technically the stuff that's in red down here at the bottom, it's underneath the division symbol. So it's like the new division problem we're doing. So we take the first one from inside, negative 5x, and we stack it on top of the first one from the outside. Now hopefully you guys notice this pattern. Every time we do that step, the little side work, it's always going to be the same thing, because that's what we're dividing by right here. So when I simplify this, this gives me negative 5. And this side work is just telling me like how many times it goes into it. So the negative 5 now, it goes up here. And every time you put something up on top, you have to distribute it to the stuff that's over here on the side. So negative 5 times x is negative 5x. And then negative 5 times 2 is negative 10. But then we have to subtract the entire quantity. So when you subtract the entire quantity, you have to change all the signs. So then this cancels and this cancels, and we end up with a 0 at the end. So that just means there's no remainder. So x minus 5 and x plus 2, they would actually multiply to give us x squared minus 3x minus 10. So when there's no remainder, it's basically, it means it's a factor. It works. It worked out perfectly. The example I did above doesn't work because it has a remainder. So they're not factors of 257. So I'm going to show you that I'll show you a couple more times. Let me take my work and shrink it down a little bit. I hope I can do it. I think I might have to use the mouse. Oh God. That's not what I want you to do. Actually, I'll just scoot everything over, except for. I don't want to do that though, because it's going onto the page. I don't want to shrink the page that's behind it. I'm just going to do this. Okay. It's because I printed from Word, so there's an image behind it. Okay. So we're going to go through that algorithm again. We're going to go through the steps. It's the same 3 steps over and over and over. So first, we're going to write it as long division. So we have 2x squared minus 5x minus 1. And then I have x minus 3. So the first thing I do is I go off to the side and I stack it. I take the first one from the inside and I stack it on top of the first one from the outside. So when I simplify that, that shows me what I need to put on the top. So if I simplify this, this is the subtraction rules from yesterday, we end up with 2x. So when I put the 2x up here, I put it above its like term. So I have 2x right here. Every time you put something on top, you have to multiply it through the stuff that's on the left end. So we're going to multiply it through here. So we end up with 2x squared. Let's see, 2x times negative 3 is negative 6x. But then we have to subtract that entire quantity, so that basically means change all the signs. So these cancel, and then we're left with 1x minus 1. Then the process starts all over again. So we take the first one from the inside, which is now the 1x, and we stack it on top of the one that's on the outside, the first one, so it's the x. You simplify that, and it just gives you 1. So that tells us what to put on top, so that's plus 1. And every time you put something on the top, you have to distribute it. So if I distribute it, it's going to give me x minus 3. Every time you put something down here, you got to switch all the signs. So that becomes minus and plus, and then these cancel. So then we end up with just 2. Now you can kind of see off to the, well, at the top, we're out of space. Like all of my like terms have something above them. So that's how we know we're done. This is right here. This is the remainder. Now if you remember that first problem we did, I put an R. That's not how we write it in this stuff. When we have a remainder in this stuff, what we do is we put plus, and then we put that number on the top of a fraction, and then we take the stuff from the front and we put it down at the bottom, back where it was to begin with. So this right here would be our answer. Now I know this is weird, but again, it's just the same 3 steps. You stack it, put it on top, distribute and change the signs. And then the process starts all over again. That sounds like 4, huh? Stack it, put it on top, distribute and subtract. I try to combine them into one, so it sounds like 3. So the last thing that I need to show you, I'm going to take all this stuff and hopefully, actually maybe I'll just move the page down. Yeah, that's better. I don't know what I just did. Yeah, okay. So I'm going to take this last one, and I'm just going to show you one other thing that you have to be aware of. Take a look at those exponents. What do you guys notice? Well, they're higher, but I think there's some missing, right? When we do long division, we have to have a spot for every exponent. So when we rewrite this into our long division problem, we're going to have to keep a spot for the exponents that are missing. So what I'm going to do is I'm just going to add 0x to the 5th to the problem. So I've got 0x to the 5th, and then plus 2x to the 4th, and then plus 0x to the 3rd, and then plus 0x squared, because those both are missing, then plus 6x, and minus 9. Now it looks all crazy, but don't panic. It's actually going to not be too bad. For the outside stuff, I don't really have to do that. So I have x to the 3rd plus 3. So this is like super long division now. Same process as before though. Take the first one from the inside and stack it on top of the first one from the outside. So I got x to the 6 over x to the 3, and that tells me that it's x to the 3. So when I put this into my answer, I'm going to put it above its like term. So I'll put it right here, x to the 3. Every time you put something on the top, you have to distribute it. So when we distribute it, x to the 3rd times x to the 3rd is x to the 6th. And then x to the 3rd times 3 is 3x to the 3rd, which ends up right here. After we multiply, then we change all the signs. So I change this to a minus, I change this to a minus, And then I do all my combining like terms. So this goes down. I don't really need the 5 anymore, so I'm just going to bring down the 2x to the 4. 0 take away 3 is negative 3. I'll bring these ones down. I'll need these ones still. 0 squared plus 6x minus 9. Do you know how to make that little thing go away? There's a way to do it, right? It's the smart ink. I hate it. It gets in the way. I did it before, but it keeps coming back. Yeah, I know. Okay, and then our process starts all over again. So I take the first one from the inside, which is the 2x to the 4. I stack it on top of the first one from the outside. And again, the bottoms are always going to be the same on our side work. So this gives me 2x. That tells me what to put on top. So I got a plus 2x over here. Every time I put something on top, I distribute. So this is going to give me 2x to the 4th. 2x times 3 is 6x. So I have positive 6x over here. After I'm done multiplying, I change every sign. Change the sign, change the sign. And these cross out. So here's our new problem. Negative 3x cubed plus 0x squared. Looks like that crosses out also. And I have minus 9. And then I try it one more time. So the first one from the inside, I got negative 3x cubed. I put x to the 3rd on the bottom. So that gives me negative 3. So I'll put my negative 3 here. Every time you put something on top, you distribute. So I have negative 3x to the 3rd. And negative 3 times positive 3 is negative 9. And then we change all the signs. So that turns to a positive. That turns to a positive. And we do this last part. This cancels, and 0 is gone, so it actually went in perfectly. So it's a factor of that big, long x to the 6th problem. So that's all the notes, and there, you still have some like space at the bottom. What I want you to do is write down those 4 steps that I told you. There's 4 basic steps to doing this stuff. So I want you to make a list of the 4 steps to this algorithm.
Yeah, pause right here. Of course not.